So, example number 3, Kristen starts an experiment with 7,500 bacteria cells. After 4 hours, there are 23,000 cells. Write an exponential function to model the situation. How many bacteria cells can be expected after 12 hours? So first, I want to start with putting my formula. My exponential formula says y is equal to ab to the x. And I could possibly have a minus h and a plus k, but we don't know. So we'll just leave it at this for right now. But what I do know is that my initial starting value is 7,500 because she starts off with 7,500 bacteria cells. Let's make that a different color. And then I know that my time is 4 hours, so that's going to be some important information. And I know that after 4 hours, I want to know about the 23,000 cells. So those are the key pieces of information that I have. I just need to know where I'm going to put them in my equation. Okay, so my equation says y equals ab to the x. My initial value is always going to be my a, so I'm starting with 7,500, so it's going to be equal to 7,500. That's an ugly zero. Let's try that again. 7,500. Then I have b. That's what I don't know. And then to the x power, and in this case, our x is going to represent the time, which is 4 years. And then I want to know in those 4 years when I'm going to get 23,000 bacteria. So it's going to be equal to 23,000. So for part A, this is my equation. It says 23,000 is equal to 7,500 b to the fourth. So this is A. Okay, so we need to figure out what b is, because if I don't have a b, then my equation is not complete, because we can't have any variables in our equation except for x and y, right? So we have to use this information that we have to solve for x. Okay, so the first thing I'm going to do is divide by 7,500. And this over here is going to become 1. So on the left side, I have b to the fourth. And then over here, these will cancel, these will cancel. So I have 230 over 75. Okay. And then I'm going to take the fourth root of both sides. And at this point, you can use a calculator. I'm going to take the fourth root of 230 divided by 75. And when you do that, you're going to get that b is approximately equal to 1.3233. We're going to do 4 decimal places. 1.3233. That's nice. Okay. Now that we have b, we can actually write what our equation is. So our equation then is going to be, so I'm going to put this in red and I'm going to put an A because this is the answer to A. Remember, equation has to have an X and a Y. So it's going to be Y is equal to 7,500 because that's what she's starting with, times 1.3233 to the X power. So let's kind of talk about this, because you took notes last time already before, and we talked about exponential growth and exponential decay. And we know for sure that this is growth because it's going from 7,500 cells to 23,000 cells. What is the growth rate? What is the growth rate? That's an additional question that I'm asking that's actually not on here. So what is the growth rate? Well, when I look at my equation, I see in parentheses that I have 1.3233. If the number is greater than 1, then that's going to be exponential growth. If the number is less than 1, that's going to be exponential decay. Excuse me, I'm sorry. So this number is greater than 1. How much is it greater than 1? It's greater than 1 by this 0.3233. So that 0.3233 is actually my growth rate. And in terms of writing that growth rate, we write it as a percent. So 0.3233 would actually be 32.33%. So my growth rate is 32.33%. So that's just a little side piece of information kind of breaking down this equation. So now that we have the function, we need to say how many bacteria cells can be expected after 12 hours. So in order to figure that out, in place of x, we're going to put 12 because we want to know for 12 hours. And you can put that in your calculator. And when you put that in your calculator, then we know that after 12 hours, there will be approximately 216,252 bacteria cells.